whole plane work. Yet you have to enable EVPN ability. This is specific to the Cisco. Okay, if you are using a different vendor, might be different command to enable it. Okay, all the configurations are done except this one. Okay, we have to create that RT for this L2 VNI as well. Okay, so let's go to EVPN, and this is going to be on the leaf switches, not anywhere else. So if I go to here, leaf switches, exit. I'm going to do here. I'm going to say EVPN, VNI of 50,150 going to be L2 VNI for me. Okay, I'm telling our device it's going to be the L2 VNI for me. Okay, and if this VNI will use RD as an auto, means it you can calculate your RD based on the dynamic calculation, then route target import going to be auto, then route target export going to be auto. Export going to be auto. Okay. Same thing we have to repeat for VNI 50151 going to say as L2 VNI use RD auto and use import export as a auto also. So you do not have to worry about anything. Okay, like this one for each and individual VNI manually you do not have to tap that import export. I'm saying under the VNI, okay, I'm going to give you import export, but use as a auto. Same thing I did for this transit one, right? So if I go here, now this is done on switch 1. If I go to switch 2, EVPN, it's a VNI 50,150 L2 VNI. This is L2 VNI for me, and make that RD as a auto, and make that route target import as a auto, and export as auto. Route target export as a auto. Okay. Then for VNI 50,151 going to be L2 VNI. I'm going to make RD as an auto, then route target import going to be auto. Okay. Route target export going to be auto. Okay. Then same thing I'm going to replicate in the here. I'm telling this each and every VNI, you are the L2 VNI, you are the L3 VNI. Okay, in the EVPN label. VNI 50,150 is going to be L2 VNI, and RD auto, route target import going to be auto, route target export going to be auto, and VNI 50,051 going to be L2, and RD going to be auto, route target going to be import going to be auto, target export going to be okay, done. Now it's all done. Let's see that what configuration I have done on the spine switches and leaf switches. So let's take example one leaf switch configuration. Okay, and let's take the verification now. If one, if I say here, okay, if I say here, Okay, so if I say this notepad, okay, take this notepad, this time, till what I have done, NV interface. After NV interface, we have physical interface. And then we're gonna have what this interface, loopback interface with BGP. Okay. Then we're gonna have final BGP configuration and EVPN configuration. Okay, this is the leaf configuration we have done. This much configuration. We have enabled that EVPN feature. We have enabled the OSPF, BGP, PIM for multicast, for forwarding MAC address. For this feature, you need to make that forwarding feature. For SBI, you have to give this. For L2BNI, you have to give this. For overlay configuration, NV interface configuration, you have to give NV overlay feature. Then we have created the given this Anycast MAC address PIM we have created. We have a spanning tree for this. We have L3 VNI with RDRT, and we have two SBIs, three SBIs. One is for transit, two is for the L2. Okay. Then we have the NV interface where we have specified the these are the two L2. This is the L3. If you want to use this to want to use L3, go to this. If you want to this want to use L2, use this group. And this is the interface towards the spine switches. This is the for routing. This is for the VXLAN, and this is the BGP and OSPF configuration. Okay, BGP with the EVPN configuration, and this is the again route target route export for EVPN for this L2 VNIs. Okay, and if you talk about the L3, let's talk about
Vijay, this is leaf switches, right?
leap switch. Yeah, tab 3 switch.
Can you please take for spine also?
Yeah, sure. I'm going to keep that.
Okay.
Tab 3. Let's take the spine 1, for example. Okay. Is so run. So only IP will be changed. Configuration is going to be same for spine or leaves, which is between that. Okay. Just to make sure that. Okay, so if I go here till leaf 3, done. Till what I taken leaf interface 3. Then I'm going to use this 2. Done. And we have PGP configuration. That's it. So spine switch will not have any kind of a VXLAN configuration. Make sure that. Okay. And make sure that before enabling any kind of configuration, you have to enable the first feature. Okay. Then you can run that any other command. If you're not enabling the feature, spine 1. Okay. Now let's go for verification. Now, this all things are done right. Our what we have created so far. This is our topology. We have created two Anycast gateway. We have created the EVPN, BGP, OSPF, PIM, all the things. Now let's bring up this host. We have multiple hosts here, right? On the topology, if you see that, we have 150 VLAN here, which is production client coming from anywhere. This is 151 VLAN. I'm going to use this 151 VLAN without VPC. Okay. After this, I'm going to get VPC, but as a flat, I'm going to select, suppose, this interface, this is spine interface for 151. This is 151, not just leaf 2. What I'm going to do here is, let me paint it out for more understanding. So we have two spine leaf switches, okay, three leaf switches. So what I'm going to do here is, we have one client, we have two client. We have 150 VLAN, okay? Then we have 151 VLAN. Okay? And for this, we have, again in the leaf 3, I'm going to give this VLAN as 150. 150. It means I'm going to make that L2 L3 communication both here. Okay, like this. What I will try to do here is, I'm going to give this subnet 172.20.150.10/24, and gateway I'm going to give like my SBI, which is rated here, any cost. Okay. Here, if I give here 151 gateway, 150 gateway. Then in between, I have here L3 gateway, okay? L3 VNI, which is 3,999. Okay, so I'm going to give 150K 172.20.150.20/24, and gateway going to be the 172.20.150.1. Okay, here for this, I'm going to give 172.20.151.10/24. Gateway going to be the your SBI 172.51.20.1. Okay, now the goal is here is, we will try to ping from here to here using the L3 BNI. We will try to ping, since they are in the same subnet, we will ping from here to there using the L2 BNI. Okay, now let's go and configure it. This interface will tag to the 150. This interface will tag to 151. This interface tag to the 150. Okay, let's go here. So the 1/3. So if I bring up this switch first and bring up this. So this is for L3 151. And if I go here, create 150 VLAN. Because each switches know about each other. You do not have to like restrict that you have to use this VLAN or that VLAN. Each switches has the VLAN 150, 151 information. So 150 traffic, if I go to here, 150 traffic will go via this. Okay, 151 will traffic go via this. Okay, forget about this traffic for now. So here will be the 151, and this going to be 151, this going to be 150, this going to be 150. Okay, the same going to be 151, this going to be 150. Okay. So let's configure it. Okay, so if I go to leaf 1 here, 1/3 interface. Interface Ethernet 1/3 switch port access, switch port mode access. I'm going to create first access, switch port access, VLAN 150. Okay, no shell. If I log into this host, I have to start it. 150. Okay, I'm going to give IP 172.20.150.10 /24, but gateway is 172.20.150.1. Okay, if I say IP range here, IP if I show IP should be so IP. So you can see that this is the gate MAC address of the host. This is the gateway. If I try to ping 172.120.150.1, it is pinging. It means I'm able to reach from here to there gateway. You see, I'm able to reach from here to gateway. This gateway. Okay, if I clean this messed up. Okay, S3 VNI. Then we have 50,000, 150, 50,051. Okay, so what I'm able to do, I'm able to reach from here to there. Okay. Okay. And I will try to configure this and able to reach 151. Okay. So if I go to this switch, if I clean this switch, enable config t. Host name I'm going to give access switch. Switch name. Access switch. Which interface is that? 1/0, 0/0, 0/1. So 0/0. So I'm going to give VLAN 150 to 151. Okay. VLAN range. VLAN 150. VLAN 151. Interface gig 0/0 towards the leaf 3, going to give no shut switch port access VLAN switch port mode trunk if I give here. Switch port mode trunk. Switch port trunk encapsulation. I'm going to use .1Q. So between the leaf and the here, I'm going to give just trunk port and we will get access port here. Okay, so we will not have any issue. Switch port trunk allowed VLAN 151. 150. Okay. No shut. Again, interface is big 0/1 towards the leaf 2. Going to give switch port more trunk, switch port trunk encapsulation .1Q. Shut switch port trunk allowed VLAN 151. VLAN 151. Okay, no shut. And so if I go show interface status. Let me minimize this page. How I can rotate somewhere in the left side or right side? Do you have any option? Okay. These both interfaces are up, And if I say here, so VLAN, to show VLAN, you have assigned it interface, no. So interface, do show interface trunk, do show interface trunk. Nothing is coming because leaf 2 or 3 are down. So in the leaf and 2 and 3, what interfaces must be? 1/5, 1/5. Okay, so leaf 2, if I go here, 3 and 50. Interface Ethernet 1/5 port mode trunk port allowed VLAN 151. Oh, 150, sorry. 150, 151 should be removed. Okay. Then create a node shut. If I go to the access switch, ports are up, so do show interface trunk. Do show IP interface brief. Interface PQ/0. Should be fine. Okay. If I go to this, by consistency states switch port mode trunk switch port trunk should be show VLAN plus 5 is associated with the 150 VLAN. Show interface, sorry. So interface trunk, if not, I'm going to give native. Native VLAN is 1, that's fine. 150 to 151 for forwarding, but allowed is to show interface 1/5. Interface is 1/5. Switch port mode trunk allowed. Switch port trunk allowed. VLAN 150. Okay. So run interface Ethernet 1/5. Fine. If I go to the access switch, it should be fine. Consistently restored. Yeah. Show interface trunk should be up. So VLAN. So run interface gigabit 0/0. Fine. Let's go to the leaf 2. Ethernet 1/5. Switch port mode trunk. Switch port trunk allowed. VLAN 151. No shut. Go here. Show VLAN. Fine. File leaf 2. So VLAN. Fine. If I go to the access switch, this is unblocking. Show VLAN. Fine. So interface trunk. Show GVP. Let's go to the neighbor configuration now. So in the neighbor, we have 0/2, which is belong to the 151, 0/2, right? And 0/3, 150. 0/2 interface gig 0/2 switchboard mode access VLAN 151 switchboard access VLAN 151 no shut interface gig 0/3 switchboard mode access switchboard access VLAN 150. Let's go to these servers and bring them up. Okay, IP config IP 172.20.151.1 10 slash 24. I'm going to give gateway 172.20.151.1. Okay, if I check that show IP should have the gateway show IP. If I bring the gateway 172.150.151.1 should have the reachability, but why not? Things no routing. Maybe interface 0/0 default interface. I'm going to do here is let's remove that. So show VLAN trunking model to show VLAN. Maybe this switch is every switch. Okay. Interface 0/0 switchboard mode access switchboard access VLAN 150. To show run interface 0/0. One port I'm going to remove. No. To show run interface keep 0/0. Fine. Same thing I'm going to do for 0/interface gig show run. So run interface gig 0/ to show run interface gig 0/1. Interface gig 0/1. No. No. Switchboard mode access. Switchboard access VLAN 151. We'll leave 1 and 3 also. 150. 50. So run interface Ethernet 1/5. So interface default interface. One slash 5. Switchboard mode access. Switchboard access VLAN 151. Show run interface Ethernet 1/5. Done. For leaf 3 also. Default interface Ethernet 1/5. 1/5. Switchboard mode access. Switchboard access VLAN, I would say 150. Now, if I try to ping from here to destination, it should ping, I believe. Yeah, it's pinging now. Okay. So now if I go to the this server, 150 server, it's 150 server should able to this 150. IP 172.20.150.20 /34 172.1. Okay. Then if I say so IP, now if I try to ping from this server 172.150.10, what is happening? I am trying to ping from here to there using the L2 VNI. This is not the L3 communication. If I go here, leave to server, if I trace route, trace path, trace 172.20.150.10. What is saying that this is the local destination, but it is unreachable through the L3 protocol. If you see that leaf and spine switches, okay. If you see the spine switch, so IP route. Do you see any kind of 172 subnet in the table? You won't see that. You won't see that here. But still, our source and destination are reachable. Via whom? Via the tunneling. Now let's do the verification how the tunneling looks like now. Okay. Now if I go and check that NV interface, so VNI interface. So if I go here, not spine switch, but to in the leaf switches, leaf one. So NVE VNI. What do you see that? See that these are the L2, but this is the L3 type. Okay. Now if I go to another run command and see that encapsulation detail. Okay. If I say yes, so NVE peer. Okay. So NVE peer. Look here, who is coming? From tab 1, it auto discovered through the control plane. It auto discovered through the control plane. Route is 5004, 5005. If you see that NV interface, this is from the leaf 2. If you go to the leaf 2, so IP interface brief. See the leaf 2, 1/9. You see the leaf 1, you will see that, sorry, 19. So 19, this one, leaf loopback 1 is for the VXLAN. You see here, so run interface NVE1. So run interface loopback 1. You will see that this is for NVE. I call this VLAN, I call this VLAN 1 under the NVE interface. So what is happening here is this particular tap address auto discovering this device and this device through the BGP EVPN. Okay, through the BGP EVPN. Now, if I go to here and run the check the EVPN table, let's check the EVPN table. Okay, IP route of tenant one. So route VRF. So IP route VRF. Sorry, IP route VRF. And then what you will see that. What you see that here. Encapsulation VXLAN tunnel ID is this one. And what you see that tag, this one, segment ID is through this one. Getting a point? This saying that for L3, so 172.20.50.20 is reachable via the VXLAN using the this particular VNID. This particular VNID. Same thing for this one. They are L3 but using the this segment ID. They're not using the local 150,000. You will not see anything 50,000 here, right? 50,000, 150, 50,000, 151 for L3 routing. In the routing table, you will see that this one. Okay, for the tunneling interface. Now, if you take a look for another platform details like NB internal platform details. So NVE platform, so NVE internal platform, I think. So internal platform here, internal platform interface details. NB, you can see that. If I check that, I have that NB1 interface, primary ID is this one, secondary ID is this one. Matlab, it means this is the source IP address, and I have three BDs for the control plane. I have three BD in the control plane, but VRF ID will see that VRF ID is associated with the one VN ID, which means this is the L3 VN ID and this is the L2 VN ID. Okay. Now, if I see here, M route details for L2 communication, because if I'm trying to ping from here to there, I have configuration here which says that if you see the NV interface, it says that for L2 communication, use this IP address. So sorry, use this group IP for to reach the destination. So if I go to here on the leaf switches and check the M route, multicast route. So IP M route details. What you will see here is, look here, coming from VXLAN encapsulation. Coming from VXLAN encapsulation, you will see the star comma G and S comma G. Star comma G means we have discovery message, some request is coming, and then we have source address on that. It means if two times flood traffic came to me, then flood traffic has got the right IP address and given the reply with the source IP address. Okay, you will see that this is the PM details. Okay, all the traffic, you will see all the traffics are going through the VXLAN encapsulation, multicast traffic. Previously, it was not happening. Okay, if I say that another routing table, so BGP BPN to verify the control plane. Okay, I say so BGP. Sorry, let's in this first. We have to so BGP L2 BPN EVPN. I'm not going to say anything. Just enter it. This is the EVPN route you are getting here. If you see here, route distinguisher, you will RD. See that I gave that auto. When I say that auto, so if you see the concept wise here, when I say that auto for route distinguish route target, sorry, route distribution RD, it says that it will use that router ID plus VRF ID. Okay, and if you see the RT value, RT will use that AS number with the uh, where is that AS number with the VN ID. I will show that where you can see that this is a unique VN ID which we are getting here. This is L2 VN ID. This is the L3 VN ID. In L3 VN ID, we have all three switches auto discovered. You will see that this is a bit complicated, to be honest. You have to understand that why this I is coming here. I means coming from IGP protocol internal. Okay, preferred means this is valid path. This is means best path. We have not advertised anything into the VGP to the EVPN, right? We have not done any kind of redistribution. This redistribution happened mutually between the EVPN and BGP. Okay, we have not done anything. We have not done any distribution to anywhere. Okay, because we are using the symmetric route concept. When you use symmetric route concept, you will find that details. If I search that specific detail, if I search 172 dot, let's say 20 dot 150.10. You see that I got this. I'm saying that please give me this destination or source IP address detail. What is showing that? It is through the BGP entry route RD value is this one. It means this is the leaf one router ID. This is the dynamic generated VRF ID for you. It's not VRF ID, it's a kind of EVPN. You can see that tagging value. You will see that advertising path is one. What do you see that AS path? And if you see that advertising path is one, but via which path? Step 2 is saying that I can reach, let me explain here, or rather I will let me cut this page. Okay, if we go to the leaf 2, where is that? Okay, so if I go to here, copy here, paste here somewhere. Here, this switch is saying that I try to search 170.150.10. It means this route is present here somewhere. Okay, on this router, the moment I search that, it says that I have path. One is going via the leaf spine one, second is going via the spine two through the BGP. If you see that, what you will see that it is going via the spine one BGP through this VNID associated to this VNID. Okay. Same thing is saying that also this is reachable via the spine 2 also. Okay. It means to reach this destination from the tab 2, I have two paths. One is via the spine 1, second is via the spine 2. You will see that RT value here. Look here, RT value. This is what I said here. In RT value, if you get the auto, you will see the BGP AS number with the VNID. VNID in the encapsulation is not the L2 VNID. It is the L3 VNID because all the communications are L3 happening here. You will see that L2 VNID also. If I go to down here, sorry, you will see that L2 VNI also. Where is that? Yeah, look here. We have L2 VNI also here. So it means EVPN L2 RIP is taking care about the L2 VNI, whereas for L3 VNI, it is via the BGP route entry with the EVPN. This is a different meaning of this. So if I go to if I go to here, this is what I was saying that showing that I am checking here. Um, on this leaf, I'm saying that 150.subnet, where it is coming from. So he's saying that, okay, I am coming here, but it is encapsulating with the 5099.999 VNID. Okay. Now, if I go to again to this, if I let's check that, verify the forwarding MAC address. What is MAC address? We have configured the forwarding MAC address, right? So L2 route, I say forwarding or past EVPN, sorry, MAC address on. What do you see that? This is for this 999 VLAN, okay, and this is the VLAN. If I go to the north, this is the MAC IP. I should search MAC IP, yeah, not MAC IP all. Look here. For 150, for this particular IP address, this is the MAC address learning from the BGP. So think about that. This L2 MAC routing is happening through the BGP, okay, via the EVPN. If you see that all three hosts are present here, which are connected from the, if you see that 150, L means local, flag means, and this is the remote label from this one. From this is the leaf 3, this is the leaf 2. If you see the router ID, okay. Let's take the more verification and how the traffic is going. You can directly open the Cisco guide for the verification command for VXLAN verification. Okay, so where is VXLAN verification? No, not this. If you say that VXLAN verification commands, so you do not need to know, memorize anything. Putting the question mark, you can just go to here. Oh, no.
You said L3 VPN learn via BGP, right?
Yes.
Can you show that one more time, please?
Oh yeah, so if I show you that leaf one, so if I run this command again, L2 BPN, if you see that L2 BPN here, BGP routing
Okay.
information for VRF, address family L2 BPN EBPN.
Yes.
Okay, it means this traffic is forwarding a traffic, this entry is coming into the L2 BPN and via the BGP routing. It means we do not have any separate routing for L2 VPN, right? Because L2 VPN is just L2 protocol. It will use, if L2 VPN want to communicate anywhere in the infra, it will use the BGP route reference for any kind of communication, for any kind of L3 communication. If you see that path one, you will see that this one flag is that flag. If you see that next hop, AS number mate, where is the by receiving label, this one. So if you see that receiving label here, right, receiving label here, label saying that
Okay.
I am coming, this traffic is 151 but converted to L3 VNI, converted to L3 VNI. If you see the RT here, RD, what we have configured here, if you see that RT is a combination of mix of AS number and the VN ID. Okay, what is AS number about? 6500. If you see that, what is the AS number we have AS number 6500, right? 6500, right? What VNID we have? We have two types of VNID. If you see that L2 L3 communication, for L2 communication we have this VNID. For L3
Okay. Can you?
communication we have this VNID.
Okay. What about L3? Can you show one L3 L3 route also, please?
Okay, yeah, sure. If I show here, so IP route VRF 10 and 1. Okay, this is the L3 routing we have. All the things is being learned via the BGP through the segment ID of this. In the L3 routing, we do not have anywhere 50,000, 50,000, 150, 151. We have just single route. Because if you see that configuration perspective also, in the NVE, I have given this to only one VR, only one particular uh, VNI, right?
Yes.
Not to this and this. I'm just forcefully telling this one, this NV interface, if any traffic, irrespective of this or this, if they want to have the L3 communication, force this traffic to this VRF And I'm saying that this particular VNID have the IP forwarding routing enabled. It means if any traffic is coming to you, forward that traffic based on your routing table. In the routing table, what you see that this is the information.
Okay, can you show that one more notepad, please?
Yeah, sure.
Yeah.
So let's type one. Okay, let's go there. So IP
No, on
address.
notepad, one more doubt I'm having somewhere. Sorry.
Sure, sure.
Okay, for example, VNI 50150, if any traffic it will come, so it will forward to VLAN 999, right? That is what you are
Yes,
saying, right?
yes. For the inter-VLAN communication, if they want to communicate, okay, that should be via
Okay.
this. If they want to communicate from 150 to 151 DC to another DC, they do not need to come to this. Okay, they can directly
Okay,
go.
but
If I
in interface NVE one,
Mhm.
we have not called any VLAN 999, right?
We have called that. Look
Like
here.
how it will forward, like how it will, okay.
We have called that.
But,
Member VNI.
no, member VNI 50999 only we called. Okay, 999
Is a
VNI called this VNI.
yes,
Okay, okay.
yes. That's if you say I
Okay,
mapped
sorry.
there. Yeah, 999
Sorry,
VLAN is
sorry.
mapped to this one.
Okay.
Okay, you will see that. So IP route RF one, same thing. You will see that 999. Okay, the same concept which I was talking about here is if it is
Okay.
L2, it's going to be the L2 based communication. If it is L3, if let's say if I try to ping from 150 to 150, from the 150 is where if I go to here, this is the 150. I think, yeah. I think if I try to ping here. Oh, sorry, I'm doing trace. Let's try to ping. Ping if I say 172.150.10, it is pinging. Okay. Same thing if I ping from this host to locally 172.20.150.20, which is present in a leaf 3, which is associated with the leaf 3. This one I'm able to reach without any disruption, without any L3 traffic. This is not the L3 traffic, this is just the L2 traffic. They are in the same subnet.
Is it possible to capture packet on 1/2 interface on between leaf and spine?
Sorry.
Is it possible to capture packet between leaf and
um,
spine on 1/2?
that is the
Between leaf one and spine.
yeah. So that is the task we have. If I to capture that is what we have issue here. Just give me a second. If I 1/2, it is not giving permission to capture. That's the only issue. I- Phew. If I, what if I say, mm, what if I say nothing? Okay. So, okay, capture is not possible to be honest. Uh,
Okay.
I have to check that how to we can enable I can capture, but thing is this is the not lab with the putty. If I can access this lab with the putty, I can capture it immediately. I tried multiple
Okay.
times, but it's not giving me that. Uh,
TCP dump is it possible, right? TCP dump.
yeah, TCP dumps we can do that. Yeah, dump on.
No, I just want to understand. That's why I'm
Yeah,
asking.
no, that's fine. Yeah, I'm okay to do that. Yeah, so let's do that. So even TCP dump, I think we have to. Yeah, so if I say here TCP dump, uh, if I dump that, or else I can show you one thing
No,
here in the
we
leaf
can get
one.
into Linux mode, right? Then we can
Yeah,
capture,
yeah.
right? TCP dump.
debug. Just give me a second. So let me do one thing. Let debug the VXLAN, right? Why even NV interface? NV interface. And say all the traffic. And let's try to generate ping from here to there. If I see anything, debug. Oh, what I can show you that. So VXLAN interface, Ethernet 1/2. Won't have interface loopback. What channel won't we have? 1/3 is running. So I was saying that this interface 1/3, which is connecting towards the downstairs, down to device, is running the VLAN with the VXLAN convergence. Okay, if I say VXLAN interface, I can do the trace. I think rather than running the TCP dump. TCP dump, we have to not sure this will support or not. Ethernet we can, I think so. Ethernet we can run. Yeah, so let's say Ethernet capture. So do Ethernet local interface. VLAN 150 capture filter VLAN no config P equalizer to local, let's say interface VLAN 150 details ported frame VLAN 1 thing format. This is the issue with the management or capture this management interface itself. Okay, if I say that, let me type the VXLAN. I don't want to see the all the traffic. It's analyzer. Sleep. If I initialize everything in the management, it's going to be mess for me to identify the traffic. So let's do the specific to the VLAN capture. If I see that, control plane traffic must be captured. Yeah, so let's do that. Yeah, so if I go here and limit that configuration, I just want to see that control plane traffic filtering is not important. Source destination, how full packet is not required. If I say this capture, okay, with the VXLAN ID is like, yeah, let me try that. This. So what is the VXLAN port number we are using here? Let's go to the VXLAN. So VXLAN. So VXLAN. Sorry. So VE. If I say adjacency, uh, VNI, some a control plane data plane. Let's see data plane, control plane. What port number I'm using? That's important. So VNI. Okay, so my NV interface is using what port number here? 47,000 something. This is equally no VXLAN. I have the VXLAN port. Nine. Going to a UDP. Capture. I'm going to enable on the leaf one. Okay. So on debug all. So as a local, I say interface inbound. I'm going to interface inbound. I'm going to select management or capture filter, capture filter, capture filter. I need to double call this. This UDP port 4789, right? Mid cap. Frame let's see. Let's initiate the traffic from here. Where is the leaf? Inbound traffic is not hitting here. Anyways, give me like 20 minutes. Let's verify. Let's do the normal verification. We'll try to figure out how to capture the packet. Okay.
Okay.
It's the virtual environment. It's sometime out of issues. Okay, the same VLAN is able to ping. Let's try to ping VLAN 50 to VLAN 51. Okay, so let's log into this production server and try to ping 172.20.151. Like if I get ping the gateway, it will work, right? If I ping the VM, it should also work. It means we are able to ping from one VLAN to another VLAN. If I should trace, not sure whether this should will there. Look here, what is showing that? It is saying that we are going to our gateway, then gateway is moving to our destination, and it is not showing that what is the where is the leaf, where is the spine. Okay, it means directly your traffic is going to gateway, and gateway is associated with the VNID, and VNID will be forwarding your packet to here, NV interface it to here. This is the control plane communication. Suppose you have the requirement to enable the data plane in your network, data plane in your network, right? So what you're gonna do here is, as of now, everything is control plane. I'm going to create one more VLAN. I'm going to create one more VLAN. VLAN like 500, and VM segment going to create 6001 something. Okay, on the all the switches pro. Yeah, and we will try to do data plane configuration. We will not call any RDRT configuration. We will not do any kind of extra configuration which we have done for this. Okay, the moment you remove this all the configuration, all the basic configuration will be done via the data plane. So I'm going to associate just, I'm going to get a VNID. I'm going to associate that to VLAN to just NV interface with the L3 uh, MCAS gateway. Okay, so what I'm going to do here is, if I go here, interface VLAN 500 VLAN segment and segment. Segment 6001 going to be for all the switches here. 50, 150, VLAN 500 VLAN segment. Sorry, segment 500. So sorry, 6001. Okay, I'm going to tab 3 VLAN 500 VLAN segment 6001. What I'm going to do here is, if I type to create NV interface, if I say interface NV 2, not possible. So what I have to do here is, I have to associate member ID, member VNI 6001. Okay. Then I'm going to say MCAS group 239.0.0.0. Okay. And that's it. I will not do anything fancy here. Same thing here. I'm not going to create any gateway in the ACI itself. Okay. This is just flat configuration. Interface MVE1. Okay. Member VNI 6001. Here I did map. Okay. Then MCAS group, I'm going to say 239.0.0.0 be part of. Then exit. In the leaf 3, interface MVE 1, member VNI 6001, and then MCAS 239.0.0.0. What I have done here is, let me keep it at plain old. I have to, I am creating the data plane configuration. Okay, one host here, one host here. This is spine, this is leaf. Spine 1, leaf 1, how data plane landing works here. We have VLAN 500, which is going to convert into the 6001. Okay. We have 6001, which is belong to the 500 VLAN. I'm going to up. There is no gateway. I need just OSPF and multicast im config on between the leaf and spine. That's it for data plane. For data plane, which already I have it. Okay. If I go to the leaf switches, so run pim. Since I have already OSPF is already running. Okay, so no need to worry about that. So here, that's it. For data plane, you do not need to enable BGP in anything. You just have to configure two protocol to make the underlay connectivity. On top of that, VXLAN VNID is already running. Okay, this is the OSPF between leaf and spine. Okay, all the same command you have to run everywhere. Now, what I'm trying to do here is I have like 192.168.100.1 subnet here, and I have 192.168.100.2 subnet here. Okay? There is no gateway in the ACI. Unlike the control plane configuration, there is no gateway. This is going to be totally flood and learn. Our traffic going to be unknown to it. It's going to flood to the this. This will forward to our destination. So let's take a look. In the here we have one client is here. So let's go to the left 3. So run NBE1 already configuration done. So run NBE1. Configuration is done. Okay, this one. And for the leaf 1 also, I say so run NBE1. Interface NBE1. If I say here now, so NVE VNI. So NVE VNI. So NVE VNI. Or should not be summary. One thing you have observed here. So let's go to this PC Ethernet 1/4 interface Ethernet 1/4 IP address. Sorry, switchboard mode access, switchboard access VLAN 500. No short for leaf is also 1/6. If I take tab 3, interface Ethernet 1/6 IP, sorry, switchboard mode access, switchboard access VLAN 500. No shit. I go to these VMs and make them power on. Okay, so if I go IP 192.168.100.1 10/24, I'm just giving the random gateway where is present. Okay, so here. Okay. Oh, it's a window. I see. Bring this window machine up, and meanwhile, let's do the L3 verification. This something is I need to figure out to capture the VXLAN. To be honest, or I can try this. Really, will it work? Not sure. If it works, that's fine. tried, I think. Analyze the local interface management, share, UDP, port 479. Let's see if it works. If I go to leaf 1, it analyze a local interface, DMT, capture, filter, UDP, port 4789. Oh, sorry, it's not bringing. See display filter. There's no. Yes, I will figure out way to fix that. I will figure out filter destination this. Anyways, let's bring this capture. Okay, guys, so let's go to this. The window is up or not? Okay, window is up now. So if I go to this interface, if I try it from this, let's see how it works. Local interface, proprietary. Or let's do one thing. What I'm going to do here is I'm going to enable the capture on this interface, this device only. Okay. So what I'm going to do here is 92.168.100.10. Sorry. 190. 168, 100.20, see 192, 168, 100.1, that's fine. What I'm trying to do, let's see if they work. I've done configuration. 20. Come on. Guys. $168, 100 dot something. Look here. What is happening? We have not done anything. We have not done anything configuration. We just created one L2 VLAN here, L2 VLAN here. That's it. This is data plane learning it happening through that. If I go to this switch one, line one, let's see. I go to this, so mcast, so IP name mcast, so IP mcast route If I show out, look here, what is showing here? You'll see that you will have that must be details. If I show IPM route, will not have any kind of endpoint detail here. Look here. It means spine is itself just forwarding the traffic through the database through using the tap address or the loopback address. It's not entering the local details because how the traffic is going. The moment traffic hit here in the tap address will use source IP and destination IP self. Source I given the his loopback address, local loop address it is. Destination going to be tap loop, destination tap loopback address. That going to be source and destination IP. It will not use source and destination IP of the leaf and spine ports. It will use the NVE VXLAN tunnel interface as a source and destination interface. If I go to capture that packet, if I try, let's see how the packet will looks like. Let's see, capture. If I edit here, now if I try to ping from here, let's see how it behaves. Look here, all the packets are coming here, but it will not give you that which protocol is this running. I believe
Here it will not show right.
no, it will not show here. Yeah, you have to capture the leaf interface in order to make that. What I can do here is I can perhaps associate this host into the 150 VLAN, right? A 151 VLAN. Let's see that if we can make that work. Interface Ethernet default /6. Interface Ethernet 1/6. If I share here switchboard mode access, switchboard access VLAN 150. If I try to ping from here to, no, it will not, but I have to change the IP address here. Let's change the IP address quickly. If I say here 172.68 dot 150 dot 21. Yeah. If I go here 172.20.150. I hope associated with the right VLAN. Again. 150 VLAN, sorry. Okay. Let's try to ping from here. Okay, the moment I see that, what you see that a lot of traffic are hitting on this with a broadcast message. If I go and try to ping this PC, what I given here, let's disable this 21, right? It's pinging. Let's see what option is coming. It is coming that traffic is coming from here. Let's stop this and check that packet. Okay. If you go to the reply echo request, in the echo request, you will don't see if there is any bit which can indicate that this is a VXLAN, because this is a totally VLAN based communication. For the PC perspective, in the data, just give me a second, guys. Somnath, UK. Just give me a second, guys. Hello. Hello. Yes, sir. Not there. Not last level, sir. Papa, हो गया. Thing is, I can capture this, but it's not like I can capture the VXLAN. So do one thing. Just give me 2 minutes, guys. Let me figure out how to capture the VXLAN packet live. Okay, then we can probably take a look and close that VXLAN control plane.
ABJ, can we continue from next week, because it has already been, more than 3 hours, right?
It's already crossed.
Yeah, and I'm in US. It's around
yeah,
4 o'clock morning, and I haven't, feeling
yeah,
too sleepy.
I totally understand that. Yeah. So if anyone is you are in US, but I can record for you that this all the configuration is done. Lab will be
Correct.
up and running. Okay, we are not going to dismantle this rack lab. I just want to capture do the capturing for the if all of
So,
you guys are okay.